Vanitha, working as a senior test automation engineer at Globant. I have been working with Globant for more than 4 years, and I have around 10 plus years of experience in the quality engineering. So today I'm going to present a topic on cognitive test automation. It's about including AI in the test automation. So let's begin with the agenda for today. So introduction about the automation process and the pain points, and then the conventional automation framework structure, and switching from conventional automation to the cognitive automation, and the cognitive automation framework workflows, and an example of conventional automation. Then I will be presenting a couple of examples for cognitive automation. And finally, I will be presenting an advantages of cognitive automation. So automation testing is a testing process that automatically tests the application using test automation scripts built top of the automation framework. This framework contains tools, utility packages, code base to create test scripts, report generator, and logs. But the challenges of automation testing alone rises at this point. Every regression or release comes with a new version of the application plus bug fixes. To make the existing automated script works against the new version, automation engineer have to debug the locators and update the script to make it work. So this is where AI can be embedded in the automation framework, where any subtle changes in the locators can be handled automatically. How? Let's discuss how the organization can move ahead with a better solution. So this is the structure of conventional automation framework. So most of the tools we have in the market currently comes with these structures like supporting packages, shoot runner, and of course with the application and a test. So the supporting packages contains application specific classes will handle the multiple test files specific to an application, web wrappers which contains class methods generalized for web testing, mobile wrappers which contains class methods generalized for mobile testing, and the test suites which contains test data handling and driver initialization, and finally the utility packages which contains method to handle the external application and tools, and the shoot runner which will handle the load properties, driver properties, environment data, and test data. And finally, the application under test. So whenever an application comes for a test, shoot runner will load the environment data and test data from the storage, and that input will be given to the application specific class. Then the application specific class will process the input and send an action to be performed in the application layer. So this process will end until the shoot completes. Finally, the shoot runner will generate a report in Excel or a JSON format. So in the project wise, how it looks like. So the application specific layer will contains the page object model, so which has multiple classes for each pages of an application. For example, for login form or a login page, we have a separate class. So login class have the method to handle the login related actions, which contains enter username or a password and clicking a button. So similar to that, we have multiple classes like registration form or a specific class file for an application. So again, the shoot runner will have the base shoots that will handle the driver initialization. For example, if you want to run the application against Chrome or Firefox or a mobile device, so that will be handled in the base shoot. And then the shoot file will have the order of the test execution. For example, login test, after that the registration, and then the application classes. The finally the test data, which contains environment data and the locator data. So the environment data contains the driver inputs, for example, Chrome or Firefox or mobile inputs or a data, and then application URL, and of course with the credentials. Then the locator data will contains the ID, class name, or XPath of each elements specific to a page. So in this process, test shoot runner will pick the data from the test data storage and give it to the application specific layer. And the application specific layer will process the data and give the action to the application layer to act up, perform an action. So this is the proposed model, like how we switch the conventional model into a cognitive mode. So here the problem is with having or maintaining the multiple classes for each application. So we will be combining application specific class layer and the shoot runner and the tester storage data into together as a cognitive model. So this will simplify the conventional model to the cognitive model. So here is the structure of cognitive automation framework. So which comes with 3 sections. One is supporting packages and cognitive test runner and the application under test. So again, the supporting packages will contain web wrapper, which will handle the method generalized for web testing. Mobile wrappers contains class methods generalized for mobile testing. And the test suites will contain the pre-trained test data handling and the driver initialization. And of course, with the utility packages will handle the external application and tools. So the cognitive test runner have 3 sections or 3 processes. So one is for handling the AI or augmented learning process, and the second one for self-healing process, and finally the decision-making process. So here you can see that application under test have the multiple application at the same time. So finally, all the execution details will be stored in the centralized or cloud-based environment for the final review process. So here is an example of cognitive automation framework. So there is a page scanner which will handle the scanning the HTML or a DOM structure. So here we have the entire HTML structure which contains multiple inputs, A tags, buttons, and so and so. So these HTML page will be scanned and processed and given to the decision-making process. And in the decision-making process, it will have a separate method to handle each and every tags. For example, if it is an input tag, it will check whether the input tag is text type or a checkbox type. So when it is a text type, it will send a key or a set of test data. If it is a checkbox, it will click or give an action to select an option in a given list. If it is a tag, it will click the link. Of course, before clicking the link, it will check whether the A tag is valid or not. So after clicking the A tag, it will perform like post verifications. And again, for button, it will perform a click action and do the post verification. So in the self-healing process layer, if an element is broken, then the process will report or log the errors and the process will continue. It won't stop the process. And again, if there is any new attribute which is unaware of the AI or a ML process, so that will be stored in a pre-learning repo and will continue the process. So again, this won't be broken or it will not stop the process. So here's the example of conventional automation or a traditional automation currently we have. So I come up with an example of registration form. A simple registration form contains multiple input fields, checkbox and a button. First name or a last name, email address and password, confirmation password. These are input types. And the checkbox for the terms and condition, and again the button. So for this model, automation engineer have to store the ID and class or XPath of an each element in a test data storage, and that locators will be given to the application class, application specific class. So the locators will be matched to the input and the action will be performed. So when this model breaks, in a traditional way of execution, if there is a locator change, this model will break. If a new field included or removed from the form, this model will break. Of course, if multiple elements contains same ID or XPath, this process will break. So in this case, the failure rate is high when a field rely on an XPath. So here is an example of cognitive automation. So I took a registration form as an example. So in this case, we have the simple input fields, checkbox and button. In the cognitive automation framework, the entire form will be scanned, or the entire HTML or a DOM structure will be scanned, and the action will be performed based on the tag type or an attribute type. So here, there is no need of ID, class or XPath or element properties. So scanning the web pages or a form and get the list of element types, for example, input, checkbox and button. So the action will be performed based on the element type. So performing actions like entering data or clicking a button based on the element type, as I mentioned. Here is another example for a cognitive automation process, link validation. So in the traditional way of execution, if you want to test a link, so the automation engineer have to store a XPath or ID of a link in a test data, and that will be given to the application specific class to take an action or perform an action. But in this case of cognitive automation model, so the entire page will be scanned and it will get all the A tags, and that will be verified or pre-verified like the A tags is valid or not. So it will click the A tag one by one and check the post verification. So here in the second layer, you can see that the A tag 1 will be clicked and that will be verified. And again, that A tag 1 will become a parent. and the child links in a particular page will be scanned and performed. The action will be performed, and this iteration will be continued until the n count or a given count. So in this case, if there is any new links included or any new links removed from a web page, the execution won't stop. So it will be self-healed or self-formed by the cognitive automation framework. So finally, there is a list of advantages of this cognitive automation framework. So the multiple application can be tested at the same time. There is no code changes required for a minor feature change or a locator changes. Automation breaking rate or a failure rate will get reduced due to the auto healing technique. So when this identifying the alternative locators is an option, smart decision making of a cognitive framework helps to proceed the automation execution without the human interruption. No need to rely on locators like ID, class name, or XPath, or any other element properties. So all the above advantages will help to deliver a product quickly. Also, in the point of product, so we will give an automation as a service as the final product. So once again, thanks for joining and hope you enjoyed the topic. Thank you.